Number 3, we're going to now keep working with those equations. It says use Desmos to graph both the equations from number 1a and 2a on the same coordinate axes. This is called a system of equations since we are working with 2 equations at once. Sketch or paste the system of equations graphs below. So when we work with 2 equations, 2 or more equations really, at the same time, that's called a system. A system is really when you have multiple things working together. Think of some other areas where you hear the word system. I don't know, I think of sports sometimes like an offensive system or a defensive system. Multiple pieces working together. Maybe in your body you have the circulatory system, the respiratory system, and those are multiple parts that are working together for a particular function. So that's kind of what the idea is here. So we're going to take both equations, we're going to graph them on the same graph, and we're going to use Desmos to do that. So I recommend going either desmos.com or bringing out your Desmos app like you see me doing here. And let's type in our equations. So we had our first equation was 4x plus 8y. Let's try that again. Plus 8y equals 16. And then our second equation was x plus y equals 3. So we're graphing both of those equations at the same time, and depending on what your window is, you might need to kind of go over here, and if you take your fingers and kind of squeeze or kind of work out from the y-axis, and then on the x-axis I'm going to kind of do the same thing just to get a nice window of values here that kind of emphasizes that part of the graph that we kind of want to look at. So you can play around with that a little bit. So that right there is our system of equations. Ooh, I kind of like that. That worked out. So you can do that same thing as well. We're going to then take a screenshot of it. And we're going to bring that in. It kind of depends on how you like to do this. I guess I'll save this to photos. Oops. And come back over, and we're going to drop that back in. I saved it to my photo library, so we're going to add that back in here. Probably should have cropped that a little bit first, maybe. I'm going to crop that so I don't have all this extra stuff. You guys are probably better at doing screenshots than I am. All right, get that looking all nice there. Okay, so there's our 2 equations graphed on the same axes. So that's what we mean by that, and we pasted it in there. All right. Now let's answer some questions. The xy coordinate value that works in both of the equations is called the solution to the system of equations. Circle the solution to this system of equations on the graph. Okay. So the solution to the system, we can see, is right there. We know that is, and if we want to circle it, go ahead and circle it. We know that is the solution because it's on both of the lines, because it works in both of the equations. So the coordinates of that are 2, 1. Solution to the system is 2, 1. It's the intersection of the lines. In other words, it's on both lines. All right, so the solution works for both of the equations because it's on both of the lines. All right, so I want you to keep that in mind. Circle the solution to the system of the equations on the tables. Okay, well, let's go back to those tables of values that we had earlier. Well, how do we know we have a solution to the system? Well, like we said, a solution is a pair of values that works in an equation. And a solution to a system of equations is a pair of xy values that works in both of the equations. So if we look at these 2 tables carefully, can you see the xy pair that works in both? You might have to kind of look back and forth a couple times. but we actually already identified it on the graph, so maybe you noticed that. And here it is. 2, 1 is in that first table, so it was a solution to this first equation. And 2, 1 is in the second table, and therefore it is also a solution to the second equation. It's the only pair of values that's in both of the tables. So we'll circle that in both of the tables. All right, so we did that, we did that. What is the solution of the system? So the solution, again, is the xy pair that works in both of the equations. We see that as the intersection point of the two lines because it's on both of the lines. It's the only point that is on both of the lines. For instance, this point right here would be on the blue line, so it'd be a solution to that equation, but not the red equation. And this point would be a solution on the red equation because it's on the red line, but not on the blue line. So it's not a solution to both. The only one that's a solution to both is the one that is on both, and that is 2, 1. All right, so what does that mean in the context of this problem? So recall, we were talking about pounds of raisins and pounds of walnuts. So the solution to 1, remember the x value, and let's actually write this on our graph, was pounds raisins. That was what was on our x-axis. That was our x variable. Okay, and then our y variable was pounds walnuts. So 2, 1 means that we have 2 pounds of raisins, since that's our x and that's our y. So, and raisins was our x and walnuts was our y. So 2 pounds of raisins and 1 pound of walnuts. And what made that work? Costs a total $16, because remember that was our first equation that we had up here, that they had to add up to $16. So we know that that works for that. Okay, and also weighs exactly 3 pounds. Where did I get that 3 pounds? Well, recall our other equation was that the total pounds had to add up to 3, so everything in that second equation that worked had to add up to 3 pounds. So this was the combination that both produced the amount of money that we needed, $16 being spent, and also produced the amount of pounds that was required, which was 3 pounds. So that would be the meaning. 2 pounds of raisins, 1 pound of walnuts would be the combination that worked.